Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello, good evening, everyone. So, am I properly audible and visible? Can you please mention the same in the chat box so that we can begin? So, how many people are with me today? So, can you please write your name in the chat box to mark your presence? And let us wait for a few minutes to the students to join, and then we can start. Yeah, so hello, can you please mention in the chat box that my screen is visible and I am properly audible as well so that we can start. Hi, hello, Asset Official Vlogs. What is your name? Can you please write your real name in the chat box? Okay, your name is Shilendra Kumar. Hello, Shilendra. And hello, Sumit as well. So, do you guys have any idea about 01 BFS and Multisource BFS? We are going to study today. So, are you ready to study? Do you know about BFS? Breadth first search. And hello, Sumit, and hello, Shilendra. I would like to request you that kindly stay with me till the very end of the session. This will be around 50 minutes to 1 hour long, and I will be covering important concepts like multi-source BFS and 01 BFS. I will also be discussing two important problems which are very frequently asked in interviews point of view. That's very great, Sumit. So, you are in your which year in college? Can you please write in the chat box? Hello, Sumit. Hello, Shilendra. Are you there? Okay, you are in your first year, first sem. That's very, very good. And that's very actually great because since you are in your first year and you already know BFS, that's kind of very great. So I would recommend you to continue studying data structures and algorithms. And by the time you come to your third year, you will be very, very, by the time you come to your internship time, you will be very much prepared. Okay, so yeah. So basically, let me give you a small introduction of the session and then we can start in just a few minutes. Okay. So my name is Gourav Kumar Shaw and I am presently in my third year at IIT Kharagpur. I'm doing my BTech here and I'm also a mentor at Geeks4Geeks. And I'm also an incoming software engineering intern at CureFit. Okay, so basically, let me tell you about the series. This is the fourth session today, And in this session we are basically covering all the important concepts related to graphs and trees which are important from interview point of view. Okay, so we already had 3 sessions in which we discussed about representations of graph, DFS, BFS algorithm. We discussed few problems as well, and we also gave a homework as well. So you will find the link of the slides in the description, and you can check out the previous sessions as well. And we will be continuing a total of 15 sessions in the entire month of December. Okay, so this is a fourth session, and we are meeting every alternate day at 10 p.m. But today I came a bit early because of some personal commitments. So today I'm live at 9:30. But usually I will be live at 10 p.m. only every alternate day. So you can see me next on the coming Tuesday. So today we will be studying 01 BFS and multi-source BFS. So first we will be studying multi-source and then 01. So can anyone tell me the difference between a normal BFS and a multi-source BFS? Hello Amit. Hello Aryan. So are just about to start with 01 BFS and multi-source BFS. So I would request all of you to kindly stay with me till the end of the session. This will be around 50 minutes to 1 hour long, and I promise you that we will be discussing 2 to 3 very important questions as well as concepts which are very frequently asked in interviews. Okay, so kindly stay with me. So yeah, and at the same time I would request you all to kindly keep a bit of interaction in the chat box so that things get pretty much easier while we are doing it. Okay, so let us start then. Yeah, so the very first problem that we are going to discuss today is about multi-source BFS. So let me give you a bit of introduction about multi-source BFS and what are those. Okay. Okay, so basically you all know about BFS. BFS basically means breadth first search. Okay, so what happens in breadth first search is that we are given a graph and we are given a queue data structures. So we start traversing from any given node, and what it does, it traverses the given graph level by level. So basically, what will do, it will first of all, it will traverse all the nodes near adjacent to the given starting node. Okay, so let us say this is our graph. Okay, and yeah, let me say this is my graph. Okay, so this is the starting point of the BFS. So during the first iteration, what it will do, it will try to traverse the first nodes that are present adjacent to it, so which are basically these nodes. Okay, so these 3 nodes come at a distance of 1 unit from the starting node. So basically, the BFS will try to cover these nodes first. After it covers these nodes, then it will try to cover the next nodes, which are at a distance 1 unit from this node, and this node. So basically, there is a level by level traversal, level by level traversal. Okay, so initially, what happens? It tries to cover the. Okay, Amit, that's very great, and I would like to congratulate you for your placements. And can you please mention the company in which you got placed? Yeah. So anyway, let us continue. So basically, BFS traversal. What happens in BFS traversal is that we go by level. Okay. So first the level 1 gets traversed, and the level 2 gets traversed, and so on. And this entire concept of level by level traversal is basically implemented with the help of a queue data structure. So what happens? We have a queue data structure, and you know what happens in queue? It's a first in first out kind of data structure. So whatever will go, it's a first in first out. Okay, so this is not a queue. Yeah, so basically what happens, whatever elements which will go inside the queue first will come out first only. So initially we put this element in the queue, and after that what we do, we take out this element and explore all its neighboring elements. So this and this and this, and then we put these 3 elements in the queue and remove that. After that we will take one of this element again and again traverse all its neighboring elements, and then we will put those elements in the queue, removing this element, again this element and this element. So we are observing certain important things here is that whatever element we are putting in first is becoming the source of the BFS. Okay. So what you know here is that the first element that you are putting in the queue is becoming the source of the BFS, and from that point onward, the entire traversal is happening. Now, since we are only putting one node in the queue, but what will happen if we try to put multiple nodes in the queue? Okay, whatever BFS you know is basically single source BFS, but we are discussing multi source BFS. So what will happen if we try to put multiple sources in the BFS? Can anyone tell me? Hello Amit, hello Aryan, hello Shilendra, hello Sumit. Are you all there with me? Yeah. So okay, so let us start then. So let us continue. Yeah, Sumit. Yeah. So let's. Okay, thank you, Shalendra. Yeah. So let's continue with our studies then. Okay. So basically, what did I just say? What will happen if I am trying to put multiple sources in the queue? Okay. So this will become multi-source BFS. Now, one thing you can observe from here is that yeah. So kindly ignore the background noise. I cannot do anything about that. So let's see one thing. So basically, Sumit is asking a doubt. He's saying that is this like level or traversal of a tree? Yes, exactly. It is a level or traversal of a tree. But BFS can be applied to any graph. Tree is just a subset of a graph culture. So the idea is that BFS traversal is an iterative traversal, and it traverses level by level, and depth first search goes into depth. So basically, since BFS is traversing level by level, we can basically exploit this functionality and try to solve a variety of problems. Okay. So let's say one more observation that I would like to all you to have is, let's say in the starting node, if let's say this is a starting node, we are putting initially in the queue, and after this node gets processed, the next few nodes will be definitely more than one. Let's say this node is connected to three nodes. So after this node gets processed, the queue will look something like this: one, two, three. It will have three nodes. Okay, now we will process these three nodes. So basically, you see that from the second iteration onwards, it is basically becoming a multi-source BFS only because there are multiple nodes in the queue. Okay, so the concept of multi-source BFS lies in this, that initially we will be putting multiple sources in the BFS and we will be continuing BFS for each of the sources. So let's say initially we put three nodes in the BFS. Hmm. And now for each of the nodes, we will be traversing according to the rules of BFS. That for every node, we will look at for the its next nodes which are present at the next level, and so on. Okay. And since we are doing level by level, we will be trying to implement some kind of functionality to solve our problem. So this will be better understood by solving a problem. So the first problem that I will be solving is the problem name number of enclaves. Number of enclaves. This is a very interesting problem, and you will find that in the Geeks for Geeks portal. Now I'm sharing my screen with that problem. Yeah. So this is a problem I have shared on the screen. So this is a problem that we will try to solve. Okay. So let's say what exactly the problem says that. Now we are given an n into m binary matrix grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent, four directionally land cell, or walking off the boundary of the grid. Okay. Find the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. Okay, so what is this saying? Find the number of land cell in grid for which we cannot walk off the boundary of any of the grid. Let us digest the statement. So it is saying that we have to find the number of land cells in grid for which we cannot walk off the boundary. Okay, so for example, let's say, let me just show you something. Yeah, in the first example, you see that there are zeros and there are ones. So you see that these three ones, as marked highlighted in the explanation part, when you are standing on any of these three ones, then it means that you will always stay inside this island and you cannot walk off the boundary of this grid. Okay, that is, you cannot come out of this grid. But let's say you are standing on this island, and if you try to move to the next, try to move one step to the left, then you will come out of this grid. Okay, but if you try to move one step left, you will fall in the water. Okay, so that is the reason. These three are the answers. The highlighted cells are represent the land cells, which if you're standing on those land cells, you basically cannot come out of this grid. Instead, you will fall into the water of the sea. So the output will be 3. Okay, so this is the question. Now let's see another question example. So as you can see in this question also, in this example also, there are this is a land cell, this is a land cell, but you cannot put this in your answer because if you're standing on this, you will basically fall off. You can basically come out of the grid by one step moving down. So basically you cannot include this. So it's kind of becoming obvious that you cannot include those cells which are basically present in the boundary of your given grid. Okay, but what about those cells which are not present on the boundary but are connected to the boundary? What about those? So can anyone just give a write a one statement about how exactly are we going to apply the concept of BFS to solve this problem? Anyone? S- Sumit, you said you knew about BFS. Can you just write a concept? How are we going to apply this concept of BFS to solve this matrix related type problem? Yeah. So let me tell you one thing. So let's come to the wide Jamboard part. Yeah. So the thing was that let's say this is our grid, and if there is a one present in the boundary of the grid, and one more thing in the question it is mentioned that you can only move in these four directions. Okay. So basically, let's say if you are trying to move, one is present in the boundary, another one is present here, another one is present here, another one is present here, and another one is present here. So basically, and rest are zeros. So do you know what will happen? So basically, if you are present on this land, you can basically come out of this boundary easily by moving one step ahead. But if you are present on this land also, then also you can come out of the boundary because these lands are connected to each other. Okay, so it doesn't mean that if you're standing on the boundary, then only you can connect. But basically, if you're standing on any piece of land which basically gets connected to the boundary in either horizontally or vertically fashion, you have to eliminate those options because you do not want to fall. Okay, so it means that you can only stay in those pieces of land which are basically surrounded by water in all the four directions. Basically, let's say if this is a let's say this is one land and it is surrounded by zero. Okay, and here is one another one. Here is another one, and here is another one. So and here is another one. Okay, so let's say this is zero. This is zero. This is zero 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 and zero 0 0. Okay, so what is happening here is that if you're standing on any one of these lands, you there is no way you can basically come out of this grid. Okay, so this is so your answer would be 1 2 3 4 5. So that is the you have to basically output that the number of land cells, which basically if you're standing on any of those land cells, you there is no way you can come out of the grid, which means that it is not connected to the any of the land cells which is getting connected to the boundary. Okay, so how are we going to solve this problem? Okay, so let's see. Any ideas? Anyone? How are we going to solve this problem? Yeah. So let me tell you one thing. What can we do here is that let's say this is our matrix. So let me just copy paste a few stuffs. Yeah. So here in the number of enclaves. Okay. Hmm. Give me a minute. Okay, yeah. So basically, let us look into something like this. Let us say that we have our matrix, and our matrix contains multiple ones. Okay, there is another one here, one here, one here, and another one here, one here, one here. Okay. So what we will do, we will apply the concept of BFS, but this time we will apply the concept of multi-source BFS. So if we are applying the concept of multi-source BFS, it means that we have to put multiple sources in our queue. So initially, what we will do, initially, initially we will put all those ones which are at the boundary ones which are at the boundary. Get it? So you will be I will be putting all those ones which are at the boundary into my queue data structure. Okay, so this is my queue data structure. I will put all the ones inside this boundary. Get it? Chalo. Okay, why am I doing that? Because I need to find all the other ones which are basically not in the boundary but are connected to these boundaries. And how can I do that? I have to traverse from the boundary. Okay, so if I'm putting this one into my queue, this what will BFS do? BFS will traverse in all possible direction and look for the next one that is present, which is connected to this one, and it will make it visited, so that we can eliminate that one from our answer. So basically, what we will do initially, we will put up all the ones which are at the boundary inside my queue, and I will mark all those visited. Then I will run a BFS, breadth first search, from all of those points, coordinates of the boundary ones, and from that it will keep on marking visited all the ones which are directly connected to the given ones in any one of the four directions. So after this BFS gets over, my matrix will mark all those ones visited which I want to eliminate, and whatever ones remains unvisited are basically my answer. I hope everyone got it. This is the beauty of breadth first search. Hmm. So Sumit is saying that we need to find the number of ones that are not in boundary. Yes, we need to find the number of ones that are not in boundary. That is good. No, but we also need to find the number of ones which are in no way connected to boundary. Okay, because there may be a one which is not in the boundary, but there is a connection between that one with the one that is in the boundary. There is a direct path. So we want to avoid that also. So that is how the breadth first search will help. So initially we will put all those ones which are at the boundary inside the queue. So and we will run a BFS. So BFS will what will BFS do? BFS will try to mark all those ones visited which are directly connected to the ones at the boundary. Therefore, eliminating our we will eliminate all those ones which are not needed. Okay, and after that, after the BFS gets over, whatever ones are unvisited, we will have those ones as our answer. We will count those ones and we will print that one as our answer. Okay, so this was a concept of multi-source BFS that we are going to apply. Okay, so let's continue. Yeah, so I'm sharing the this tab, the problem tab. So how exactly are we going to do it? Hmm. Yeah, so the first and foremost thing is that we need to declare a queue. So can anyone tell me what will be is this queue of integers? Yeah. So let us look into this. So at first, I have declared a queue which contains a pair. So pair basically, I need to store two values, the coordinates, because we have our graph is given in the form of a matrix. So matrix basically has two coordinates I comma j. So I will store in the queue. Now I have int n is equal to grid dot size. So this is basically the number of rows, and int m is equal to grid of 0 dot size. So basically this is the number of columns. Okay. So I hope everyone understood it. Hmm. N and then m. Okay. Yeah. So now I also need to put up a visited array as well. So this is also a visited array, a matrix you can say, because it is two dimensional of n rows and m columns. Okay. So basically, yeah. So we have declared our queue, we have declared our visited array. Now what is next? Now next we need to traverse our given row. Why do we need to traverse our given row? Because yeah, because we need to find all those elements which are present in the boundary of our given boundary of our given matrix, and so that we can put it inside our queue. So basically what we are doing, we are running two nested loops to traverse our given grid. So we are checking whether it is present in the boundary or not. And what does it mean if it is present in the boundary? It means that it is either in the first row or in the first column or in the last row or in the last column. So if either I is equal to 0, or j is equal to 0, or I is equal to n minus 1, or j is equal to m minus 1. In these cases, what will happen? It is basically the boundary grid, boundary cells, and we have to check whether it is equal to 1 or not. If it is equal to 1, we will just push the coordinate into our queue. So this becomes the initial sources of the multi-source BFS, and at the same time we will mark those cells as visited as well, because though we are not including those in our answer. Okay, so it makes sense that we should mark them visited. Okay, this is done. Now what we will do? Now we will do a run a BFS. So how exactly are we going to run a BFS? Let's see. So first of all, we need to run a while loop. Okay, so let me explain you to the BFS part. Okay, so yeah, So let us look into the BFS part. So what will happen? We have initially put up the all the multiple sources of our of the boundary cells in our into our queue. Now we will run multi-source BFS from each of one of those cells. So we run a while loop. And what does the while loop do? It has to we declare two variables. The first is the row variable, which will basically take the first element of our of the coordinate, which is basically the ith, and the second element. So I know the row. This two values are giving me the coordinate of the of the node under consideration or the cell under consideration. And as usual, we will remove that element. Now the thing is that we will be traversing in all four directions of this given cell, that is given row comma column. We will be traversing in all four directions. So with the help of these two arrays, basically I can easily traverse in all the four directions. So what will I do? I will just add row plus del row of I. So initially it is -1 in del row and del column it is 0. So what will happen initially? Initially it will be row -1 and col plus 0. So basically if you want to traverse in all the four directions from row comma column, so basically it will be +1 -1 and in both rows and column horizontal and vertical direction. So running a for loop from 0 to 4 and doing this operation will help us in every iteration we are moving to a new path. So initially basically we are moving to the coordinate row plus 1 and column. In the second iteration we will be moving to row comma column plus 1. In the third iteration we will be moving to row plus 1 and column. In the fourth iteration we will be moving to row and column -1. So in this way we are moving to all possible four direction horizontally and vertically. Now the question that we need to check is whether it is a valid move or not. So if n row is greater than equal to 0, that is a new row. N row basically means a new row is greater than equal to 0 and n row is less than equal to n. It means that it is within the boundary of our grid. And if n column is also greater than equal to 0 and less than m, it means that it is in the boundary of our grid. If it is within the grid, and the second thing, if it is not visited, okay, if it is not visited, this is also important condition. And if the number present in that grid is 1, okay, so these three conditions must be satisfied. The first condition is that that must be a valid cell that in which we are moving. The second condition is that it should not be visited, okay, that it should not be visited already. So basically the visit of enrow and encall should be 0. So because it is not visited, then we will only try to visit it by doing a BFS. Third condition is that it should be 1, because we are trying to eliminate all those ones which are connected directly to the boundary ones, okay. So if these three conditions are met, then only we will push that into our queue. So we'll push the new row and new column into the queue, and at the same time we will mark those visited as well for the next BFS traversal. So after this entire while loop gets over, we will get all those cells marked as 1, or all those ones marked as visited, which we do not want to include in our answer because they're somehow or the other connected to the boundary cell. Okay, so after that, whatever ones remains will be our answer. So now the answer is just simple. We will maintain a count variable, and what we will do, we will just look for all those ones which are basically not yet visited. Okay, so let's write the code snippet for that. So this is the code snippet for that. Okay, so int count equal to 0. Okay, so what will I do? I will be writing from int I equal to 0 to n. So basically I'm traversing the entire matrix and we're checking for the unvisited array. So if it is a 1, if the cell under consideration is 1 and it is not visited, so what we will do a count plus plus, and finally we will return count. Okay, so because that will be our answer. So let's submit this code and check. Okay, so this code is basically correct. Okay, chalo. So I hope everyone understood it. Can you please do a +1 in the chat, those who have understood this concept, so that we can move to the next part. Thank you, Sumit, for understanding. Hello, uh, Silendra, are you there? Let us proceed to the next part. So next I will be discussing about 01 BFS. Okay. Now I will be discussing 01 BFS in a quite concise manner because it is kind of an advanced topic and we will be discussing more questions later on. Okay. I will just give you a gist of 01 BFS and later we'll, if time permits, we'll move to another question. Okay. So what does 01 BFS means? So we learnt about normal BFS, we learnt about multi-source BFS. Now what exactly is 01 BFS? So 01 BFS, by the word, it means that we will have two options. Okay. So let us see something. Whenever we are, let's say this is our node, and this is a particular node that is under consideration. So what does the normal BFS do? It keeps on traversing. It looks for all the adjacent nodes to this given nodes, or all the nodes which are at a level one, that is, which are directly connected to my given node. Okay. It tries to find that node, right? Hello, Sumit. Do you have any doubt? Okay, so we can continue then. Yeah. Yeah. So BFS, what does BFS does? Let's say this is our node under consideration. Okay. This is our node under consideration, and what will the BFS do? BFS, because this is inside of a queue. So it takes this node out of our queue and it explores all the nodes which are at a distance of 1 unit from this given node. Basically, all its adjacent node. So it will try to visit. It will try to take this node and it will put in the queue. It will try to take this node and put in the queue, and this node it will put in the queue, and then this node. But is there any order in which these four nodes are getting visited? No. Basically, whatever input we will get, it will visit in that fashion only. Let's say if you have got a list, and the list in the list it has been said that this node is coming first. So basically, it will go in that fashion. So there is no priority. Okay, it's not like that. This node. I want to keep this node early and then this node at the end. It's not like that. Okay. So whatever order it will go inside the queue, it will be processed in that fashion only. So let's say if this node is going first, then only this node will come out first. Okay. But what will happen in BFS? I want to put up a preference order. I want to put up a preference order. Okay. So let's say if there are two nodes, okay, connected to the node under consideration, and I want that this node is is put in the queue at the beginning, and this node is put in the queue at the end. Okay. Because what will happen? I want this node to be processed first before this node. Okay. So in that case, let's say this is my queue, and so if my BFS is basically traversing this node, it will try to put it at the end of the queue. Okay, because queue is nothing but first in first out. So basically, this will be processed after all the nodes in the front are processed. But not, I don't want that. I want that this node to be processed in the very first only. Okay, so in that case, what will I do? I will put up a like a kind of a virtual weights. Okay, so I will say that the node connected these two nodes, the H has a weight of 1 and this has a weight of 0. Okay, so whatever, if the weight is equal to 1, what we will do, we will put that in the front of the queue. And if the weight is equal to 0, we will put it in the back of the queue. So basically, we are kind of giving up a partiality to this kind of node. Okay, so that it can be processed early. Okay, so how can we implement this BFS? Because we cannot use a queue because there is no functionality in queue which may permits us to put up an element in at the beginning. We must put it at the end. But now I want that queue to be processed in the beginning. So how can I implement that? Can anyone tell a data structure which will help us do that? So can anyone tell me a data structure which can help us do that? Okay, Sumit, yeah, got it. Now I think I'm audible. Right. Hello. Yeah, so, okay, so can you, Sumit, can you explain how you are saying a priority queue? Like what happens in a priority queue? So basically, whatever element has a value so highest, it comes on top of the priority queue and it will be accessed first. Okay, but we do not have any value of the node which we want to put. We basically have only two options: either we want this or we want this. Okay, so how can we do that? Okay, we will be doing that in the by using dq. Okay, so by using dq, as Manju said. Okay, hello Manju, are you there? I would request you to kindly stay with me till the end so that we can learn this concept very well. Okay, so basically, we will be using a DQ. Okay, now we will just do a normal BFS, but at the same time, we will do one more thing. What we will do, we basically will check the weight of the connected edges. So we will see if the weight is equal to 1. It means that if the weight is 1, what will I do? What will I do? I want to give it a special treatment. So basically, what will I do? I will push that node in front of the DQ. Okay, because I want that node to be processed earlier than all the nodes which are basically inside my queue. And whatever nodes will have a value 0, the edge will have 0. I will put it in the back of the DQ. So DQ is a data structure which allows this functionality, and we will be using this. Okay, so this is the concept of 01 BFS, but we have to do a problem to understand this concept. So there is an article on Geeks4Geeks which I'm going to explain it to you, which will basically show you the functionality of this. Okay. Yeah, so let's come have a look at this. So basically, yeah, so the question says that we have to find the shortest path in a binary weight graph. Okay, so I would request everyone to kindly read this article. I am posting it in the chat. Okay. So this is an excellent article on to understand how exactly the 01 BFS works. So here it is saying that every graph has a edge has a weight of either 0 or 1. A source vertex is also given in the graph. Now we have to find the shortest path from the source vertex to every other vertex. So let's say our source vertex is equal to 0 and our shortest path will look something like this. Okay. So let's say our input is something like this. Shortest path will we have to basically output a array, distance array, which will basically put up a shortest path. That is, shortest path from 0 to 0 will be 0. The shortest path from 0 to 1 will also going to be 0 because the weight is 0. The shortest path from 0 to 2 will be 1, and so on according to the input. Okay, so how exactly are we going to solve this problem? Okay, so we are basically going to solve this problem by using a 01 BFS. How exactly? Let us see. So first of all, we basically will have a structure to represent the edges. Okay. So this is a structure that is representing the edges. It is denoted by two variables. The first variable is basically the node it is denoting, and the second is basically denoting a binary value. It is either 0 or 1. Okay. And according to that, this particular weight, we will either put it in the front of the DQ or at the end of the DQ. Okay. So the first thing is that we basically need to have a distance array. Okay, we don't need to have a visited array because that won't help us much. So we will be having a visited array. Okay, so and this is a vector which is basically storing our graph adjacency list. Okay, what happens in a normal value? Normally, what happens? We have an integer value representing the nodes, but we have put up a structure. We have declared a structure which contains two values: the node number and the weight associated with that node. Okay, so this is how things will proceed. Okay, so it contains two values. Okay, so now we will be declaring a distance array, and initially we are basically putting all the values as int max. Okay, why exactly? Because we want to minimize the distance, right? And it will help us to to check the condition of minimization. So now we are declaring a DQ, and we will do exactly those things which are basically we do in a normal BFS. So we will initially put up the distance of the source as equal to 0. Okay, just like we make a you can basically imagine this distance array as a visited array. Okay, so now what we will do, yeah. So now what we will do, we will push back the source in the DQ. Okay, since DQ is empty right now, we will just push back one element into the DQ, and we will run a normal BFS. So what we will do, we will take the front element of the DQ because we want to process that early, and we will just remove that element from the front. Okay, now what we will do, we will process all those elements which are adjacent to the given element. And how we will do that? By running a for loop. So this for loop will run from I equal to 0 to I is less than edges of V. So edges of V dot size basically means that it is running through all the edges. So if let's say 3 edges are connected to the starting node, let's say we are starting from node number 0 and 3 nodes are connected, node number 1, 2 and 3 are connected. So it will run from I is equal to 0 to I equal to 3. Okay, so basically this vector will this array will give us the 3 nodes. Okay, now we will check the optimal distance. Now we have to basically, what do we have to do? We have to minimize the distance. So what we will do, we will check whether the distance of the node we are trying to reach, that is yeah. So basically what we will do, we are trying to check the optimal distance. So let's say the distance of this edge. So edges of v of I dot 2. Dot 2 means the node we are trying to reach. If that distance is greater than the distance of my present node plus the weight of the edges. If that is greater, it means that we can update that distance because we want to minimize. And if an already greater distance is present, so my work is now to minimize the distance. So what will I do? I will just update with this value. Okay. So because let's say if you're standing on vertex number v and you want to reach to the vertex number v plus 1. So what will you do? You will you will basically add the two distances, the distance till vertex number v plus the edge from v to v plus 1. You will do that. So basically if you see that the distance is if in the distance array, if it is greater. But now let's say I want to just give you an input here, that we have already declared our distance array with int max. Int max is a very high value. So if let's say if we have never visited that place, so basically this will contain a very high value int max. So this will always be true. And basically we are at every step we are trying to minimize the distance. So we will update that distance. Now we are done. Okay, we have updated the distance, but our work is not done. So basically what we want here is that we will see whether the weight is 0 or not. If it is 0, we will push back in the front of the queue, dq. And if it is equal to 1, we'll push back in the back of the queue. So what will happen? The weight, which are basically 0, will be processed first now. So this edge, which has a basically weight 0, will be processed first. And now again, we will try to find the distance from here. Okay. So this is exactly how we are finding the shortest distance. And after that, what we will do, we will just print the short distance array, and we are able to get the shortest distance from the starting point only. Okay. So I hope everyone understood this. So any doubts here? Yeah. So this was the concept of multi-source BFS and 01 BFS. Okay. So I hope everyone got it. So let us look into one more problem. We have some amount of time left. Yeah. So the next problem will involve the concept of multi-source BFS again. Okay. So this is the problem. Now the problem says that we have to find the nearest cell having 1. Okay. So given a binary grid of n into m, find the distance of the nearest one in the grid of the each cell. So I will not be showing you the entire code of this question. This is also a BFS question, and this question will be added as a homework. Okay, I am adding the link to this question uh, in the slides. Okay, so okay, so I have added this question in the slide. So I would request everyone to kindly solve this question after the session ends. Okay, because we will not be having time to implement this entirely, but I will show you, I will tell you, explain all the problems that I needed to solve this problem. And it's also a very easy problem similar to the first we did. Okay, so let us see. We are saying that we have a binary grid of size n into m. Okay, now we have to find the distance of the nearest one in a grid of each cell. The distance is calculated as something like this. That we will basically subtract the row numbers and the column numbers and we will add them. Okay, and we will also take the absolute value of the differences of the rows and the columns and do an addition. So where I1 and J1 are the row number and the column number of the current cell, and I2 and J2 are the row number and the column number of the nearest cell having one. So let's say this is our input grid. Okay, this is my input grid. Now this is our distance array basically. So what do we? The question is saying that we have to find the minimum nearest one in a grid for each cell. Find the distance of the nearest one. So since this is a 0, the first cell is a 0. So what is the distance of the nearest one? As you can see, this 0 is basically surrounded by zeros in its two directions. So this is a distance at a distance 1, because if you just do a distance 1, this will take a 0 1, and this will also take a 1 distance. Okay. So let me just paste this stuff here and explain it to you. Okay. Okay. So this is my distance array. I hope everyone can see this. Okay. Let me just do a bit of magnification. Yes. Okay. So the question is asking, we have to basically find the, for every cell, we have to find the nearest distance of the nearest one. Okay. We have to find the distance of the nearest one. So let us consider this cell. Okay. Let us consider this cell. So what is the distance of the nearest one? And distance is calculated something like this, that let's say if you're standing at two values ij, i1 j1 and i2 j2. So distance is something like this, modulus of i1 minus i2 plus modulus of j1 minus j2. Okay, so this is our distance, right? So let us say what is the distance of the nearest one from this 0. So as you can see, it is at a distance 1, because 1 minus 0 will be 1 and 0 minus 0 will be 1. So the distance is 1, and this one also the distance 1. So basically the nearest one is the distance 1. So we will put our answer equal to 1 in the first cell. Okay. Now the second cell is already 1. So what is the minimum distance for nearest one? So it will be 0, because it is itself a 1. So this will be 0. This will also be 0. Okay. Now this is a 0, and it sees that the nearest one is 1. Again, because it is present on the left side. Okay. Now this is a 1, so answer will be 0. This is a 1, so answer will be 0. Now this is a 0, but 1 is present on its top and left side. So answer will be 1, because it is at a 1 unit distance. Now this 0 also has a unit 1. Okay, basically, so it is present on the bottom. So I will just put a 1 here as well. Okay. Now this is a 0 and this is a 0. It will also have a distance of 1 unit. Okay. Now this will have a distance of 0, 0. Right. So basically this will be our answer. Get it? So as in the question also something like this has been given. So this will be our answer. But you know that's there may be possibility that something like this is present. Let's say there is a 0, here it is a 0, here it is a 1, and here it is a 0. So if this matrix is given and I want you to write the answer, what will you write? In the first case, it is 1. So basically, the answer will be 1. In the second case, it is connected just by a distance 1 unit. So answer will be again 1. But sorry here, since in the 0 comma 0 itself, the input is 1. So the answer will be 0, because that is itself the nearest one that is present. So in the first case, it will be 0. In this one, it will be 1. And in this one, it will be 1. But do you know that in this case, in this number 2 comma 2, the answer will be 2, because in order to this is the nearest one, and you are not supposed to move diagonally, you are supposed to move horizontally or vertically. So let's say the coordinate of this number is 0 comma 0 and the coordinate of this number is 1 comma 1. So the distance between two according to this formula will be 1 minus 0 mod plus 1 minus 0 mod. So it will be 2. So this will be our answer, and you have to implement this concept using uh, hmm. so you have to implement this concept using uh, how will you implement this concept? Okay. So let me tell you that you can apply the concept of BFS to solve this problem. Okay. So this question is basically a homework for you all, and I would like you all to solve this question. So I will also give you a small hint that what you can do here is that you can maintain a BFS, and you can have a Q data structure. And inside that Q data structure, what will you do? You will put up uh, Hmm. So basically, what you will do here is that you will start a BFS with all the grid which contains 1. Okay, because initially we'll put up a distance array, okay, which will be your answer, and fill the distance array wherever there is 1. You can fill the distance array with value 0, because that's the answer will be 0. Now you do, or you run a loop and you traverse across all the cells and you see if it is equal to 1 or not. If it is equal to 1, you just push that into the queue and mark that visited. And if it is not equal to 1, you just mark it 0. Okay. Now what you do, you run a multi-source BFS, and if you run a multi-source BFS, you take any particular value of 1 and you go across all the 4 directions. Okay. Okay. And when you go across all the 4 directions, just check whether that particular value is a 1 or a 0. Okay. So if it is a valid, if it is equal to 0, then what you do basically, you mark that visited and you increase the steps also. Okay, because if you are moving in 4 directions, so basically it means that you are moving in one step, because the beauty of BFS lies in that the BFS algorithm traverses in step by step fashion. Okay, so if the iteration it is moving in one step, it means that it has basically moved one step forward. So from the initial point, the distance to that number is 1. So you will update in that fashion. Okay, so you can just simply apply a multi-source BFS, and similar to the problem we did in the very first problem that we did, find the number of enclaves. Exactly the same problem is there, but in that we have to just count. But here we have to maintain a distance array and keep on increasing the distances as we move ahead in our iteration. Okay, so this brings to the end of our session. Do you have any questions to ask? Okay, so hello Sumit, are you there? Did you like the session? Hello Manju, are you there? So Sumit is in first year. So Manju, can you please mention in which college you are in and in which year you are in? Okay, Sumit is asking, you are in your first year. I have solved around 380 plus question in DS Algo and Geeks still not feeling that fluency in problem solving and can't solve all the problems in coding contest. Okay. Basically, I will, Sumit, recommend you to kindly follow a guided approach. So what you can do is that you can start, if you have solved already 380 problems, I think if you've solved across all particular values, so it seems like you have to keep on trying basically, right? See, the quantity doesn't matter, the quality matters. Okay. So what you can do here is that if you already have gotten all the topics covered, then I would recommend you to solve a question without looking at the solution. Okay, it may happen that you are looking at the solution too early. In that case, the problem solving skills are not getting developed. Okay, so that is not a good thing to have, right? You are in your final year and from Tamil Nadu. Okay, Manju, that's very great. So, did you like the session? So, I would request you to kindly like this session on the YouTube and also subscribe to our channels. So, basically, we can bring up similar contents in the future as well. Yeah. So, Sumit, you got it. Like, you can basically try a problem but do not look at a solution. Okay. See, if you have solved 380 problems, and if those 380 problems covers all the concept, it means that whenever you are trying to solve a new problem, the new problem, the concept in that new problem will basically be somehow related to the old problems you have solved. So either you are not able to relate the concept of the new problem to the old problem, or you do not know that problem already, right? So if you do not know that problem, then learn. If you already know that problem, then try to remember how was the problem related to the previous problems you have solved. Like this only you will be able to improve your problem solving skills. Okay. So I guess we have moved to the end of the session, and thank you for being with me. I will again meet up on Tuesday, that is day after tomorrow. And in the next session, we will be learning about maybe we will do a bit of problem solving sessions, solve a 3 or 4 more problems, and then we will move to the next topics of graph. And then finally, we will move to trees. Okay, Sumit, welcome. Thank you, Sumit. Thank you, Manju. Thank you, Shailendra, for being with me today. And a very good night to everyone, and all the best for your career and preparations. Okay, bye bye.